Lightning is the most spectacular phenomenon in our atmosphere. It can be grouped by the location in which it is formed. Cloud-to-cloud lightning flashes are usually horizontal, and their length can reach 40 to 50 kilometers. Intra-cloud lightning flashes have a maximum length of a few kilometers. They are only seen as short bursts of light. We cannot see any branches. These two are the most common types of lightning. About 65 to 75% of the lightning flashes we see fall into these groups. Another, relatively rare type of lightning is cloud-to-air lightning. The most spectacular type, however, is cloud-to-ground lightning, which is a few kilometers long. The modern scientific explanation for lightning was based on experiments conducted by natural scientist Benjamin Franklin, who was one of the founding fathers of the U.S. In 1752, he flew a kite to show that it can draw electricity from lightning, thus proving that clouds are electrically charged. Today, we know that clouds consist of water vapor, which freezes at great heights. The motion of the ice crystals that form is influenced by gravity and the buoyant force that is supplied by the upward moving warm air. As these forces are opposite in direction, the ice crystals are constantly moving and rubbing against each other, which causes them to build up an electrostatic charge. Upward moving ice crystals become positively charged, while downward moving ice crystals become negatively charged. As a result, the upper part of clouds becomes positively charged, while the lower part becomes negatively charged. The negative charge accumulated in the lower part of the clouds repels the negatively charged particles located right below the Earth's surface, and therefore the ground becomes positively charged. Consequently, an electric potential difference occurs between the clouds and the Earth's surface. This difference is equalized in the form of lightning. When we see lightning, plasma is formed, which consists of positively charged ions and freely moving, negatively charged high-energy electrons. After a while, the high-energy electrons return to their lowest energy states. During this process, they transfer their energy to the environment in the form of light and heat. The photons thus produced are perceived as a burst of light, which we know as a bolt of lightning. The plasma is capable of heating up the surrounding air within a very short time. The temperature of the air may reach 30,000 degrees Celsius, at which point its volume suddenly increases. As the plasma disappears in a fraction of a second, the air cools down quickly and its volume decreases. As the volume of the air rapidly increases and decreases, we hear an explosion-like sound called thunder. During a strong thunderstorm, bursts of light may occur even above the clouds. These are electrical discharges which are, in turn, caused by lightning bolts that create an electric field between a thundercloud and the ionosphere. These low-pressure atmospheric phenomena are only visible for an extremely short time. They are named after their color and shape. Red sprites may appear column-like or take the shape of a jellyfish. Blue jets project from the top of storm clouds. They are blue and more luminous than red sprites. Elves often co-occur with red sprites. They appear as enormous flat disks. About 1.5 billion lightning bolts are formed in the Earth's atmosphere annually, though they are not evenly distributed. Lightning is more likely to form above land than over the sea. Moreover, it is more typically formed in the tropical zone. Lightning is rare in the polar regions. In Norse mythology, Thor is the god associated with thunder and lightning, while in Greek mythology it is Zeus. Even today, the folklore of numerous cultures consider lightning as an expression of the god's anger. Lightning strikes pose a serious threat during thunderstorms if one is caught at the wrong place at the wrong time. Every year, thousands of people are killed by lightning or by fires caused by lightning. During a thunderstorm, it is recommended that shelter be sought in a building or in a car. If this is not an option, hilltops and trees should be avoided, especially single trees. Tall buildings can be protected against lightning strikes with lightning conductors that convey the electrical charge into the ground and thereby prevent the building from being damaged.